Hey guys, welcome to Tampa Bay Estuary. My name is Kiara Martinez, and I have been living in Tampa Bay area all my life. My parents were born and raised here and love the area so much that they decided to stay and raise me up here as well. Tampa Bay, Florida's largest open water estuary, is located on the west coast of Central Florida and has an average depth of about 4 meters and an area of 1,000 kilometers. It is a highly urbanized watershed and supports one of the most active shipping ports in the U.S. The watershed is nearly 5 times as large as the bay. Crazy, right? Almost half of which is urban/suburban land use. Our input of fresh water includes the Hillsborough, Barrow, Alafia, Manatee, and Little Manatee rivers. We depend upon location, freshwater discharge, precipitation, tides, and winds. After decades of rapid urbanization and associated water population in the late 20th century, Tampa Bay is widely recognized as a national environmental success story due to the reduction of nutrient loads, increased water clarity, and dramatic recovery of seagrasses. The Tampa Bay estuary encompasses freshwater, salt marsh, mangrove, and seagrass habitats, as well as spawning and juvenile fish habitat. You can see that it involves a variety of marine organisms and ecosystems. Significant impacts to the Tampa Bay's water quality and ecosystem has been documented as a result of early coastal development and urban expansion that occurred between the 1950s and 1980s, which makes sense because the population has quadrupled since the 1950s. By the late 1970s, eutrophic conditions, including phytoplankton and macroalgae blooms and seagrass losses, were evident. The overall focus was on improving Tampa Bay and obtaining sufficient water quality. Coastal waters have been significantly influenced by increased inputs of nutrients that have accompanied population growth adjacent drainage basins. Recovery of seagrass coverage in Tampa Bay, Florida to levels observed in 1950 is a long-term goal adopted by local, state, federal, and private partners participating in the Tampa Bay Estuary Program. Nitrogen controls initiated in 1980 and continuing through present from wastewater treatment facilities, stormwater treatment, fertilizer manufacturers, and power plants, resulted in a 60% total nitrogen load reduction compared to the mid-1970s. As a result, annual water clarity targets are being met, and seagrass coverage in 2008 was the highest recorded since 1950, but still 3,380 HA lower than 1950 coverage. However, seagrass coverage in all areas of the bay is not increasing at the same rate. Localized water quality factors, including color dissolved organic matter and turbidity, may have impacts on seagrass growth in other areas. Since this time, Tampa Bay's estuarine water quality and ecosystems have significantly recovered due to a long-term water quality monitoring program, first established by the Environmental Protection Commission of Hillsborough County. They have had an effect on seagrass recovery in Tampa Bay, but it will take more than maintaining a successful nutrient management strategy to reach the recovery goal. Now to pollution and how it has affected the Tampa Bay estuaries.
Hi, I'm pollution. I am a huge issue for the Tampa Bay area, but I am present because agricultural, residential, commercial, and mining practices all and produce me to do its daily activities. I have many different forms, but today I will be talking about when I am mainly in the form of excess nitrogen and microplastics in Bay. I also have been called to have non-point and point sources. Point sources are more easily to identify and find a solution to, while non-point sources can be very difficult to identify and even harder to find an overall solution for. A main way I get produced is by wastewater treatment facilities. They have upgraded wastewater treatment facilities technology because I was one of the main point sources of how excess amounts of nitrogen was getting into the bay. In early April 2021, one of the facility's reservoirs was giving away, and they had to drop the load and dump 100 million gallons of wastewater into a ditch that leads to the bay. The state then approved to dump all 480 million gallons. The wastewater is considered and was considered contaminated because it had been from an old phosphate mine and had been mixed with other water sources. I will enter the bay eventually this way, and whenever there is a leak in one of these facilities, I end up doing a lot of harm. My beloved utility companies love to release me in the form of atmospheric nitrogen oxide. In 1999, they were told that they needed to reduce these atmospheric emissions. I understand that I can be very harmful, but it hurt knowing that they wanted to see less of me. Fertilizer manufacturers are also a huge contribution in creating me. Fertilizer manufacturers can cause an excessive amount of nitrogen loading. I end up in the water and deplete its oxygen and cause poor water quality. The people need to eat and also have nice lawns. Nitrogen and fertilizers makes it very good for the plants. Sometimes I like a free ride to the bay, and because my presence there is in abundance. Luckily, I can rely on stormwater runoff. When it rains, the water picks me up and drags me to the bay. I am seen in higher concentrations when it rains, whether it be in nitrogen levels or microplastics. Speaking of microplastics, this is another form I am seen in Tampa Bay. Microplastics are tiny, tiny little plastic particles that have degraded from your big plastic particles. But the concentrations in discrete water samples range from 0.25 to 7 particles per liter, with an average of 0.94 particles per liter in the bay. I am seen in the bay in this form because of tourism, littering, and just people using plastic in their everyday lives. With the growing Florida, I have been cracked down on. The city and environmentalists want to keep the bay in good shape, so supposedly I need to be limited. Now on to Sally the scientist to explain how I am limited.
Hi, I'm Sally the scientist, and I'm here to tell you that while water pollution is a large-scale issue, there are several successful solutions that have been implemented to reduce nitrogen pollution at Tampa Bay. One main reason why Tampa Bay has been successful in reducing water pollution is attributed to the collaboration between scientists, decision makers, and managers of local, state, and federal agencies that work together to develop the nitrogen management strategy. This strategy included adopting a minimum seagrass cover based on the 1950s cover, setting light requirements for seagrass species, water clarity levels, maximum chlorophyll A levels, and nitrogen levels based on National Academy of Science and National Research Council recommendations on eutrophication. This strategy has been very effective in reducing pollution because it outlines specific measurable target goals. The other main reason is that the private sector has been willing to work together to implement reduction goals. The Tampa Bay Estuary Program created the Nitrogen Management Consortium, which is a group of local utilities, industries, agriculture, and local government. This consortium worked together to develop the Nitrogen Management Action Plan that members voluntarily implemented. Some of these actions included providing advanced wastewater treatment in all municipal wastewater treatment plants to clean the waters that would enter the bay. The phosphate industry included best practices to reduce nitrogen loading in the ports where their fertilizer products were shipped from, stormwater upgrades, and agricultural best practices, which not only improves water quality of the bay, but improves the standard of living for people living near the area. I have noticed that in some areas, seagrass recovery rates differ. So one method I've used include having volunteers plant seagrass plugs. And after 2 years, we saw recovery. Two other smaller solutions that would be great to include would be working with homeowners and other building owners about fertilizing their lawns and engaging youth through citizen science to monitor water quality levels in the bay. Strategies to reduce conflict with property owners would include educating owners about the importance of limiting fertilizers and providing help with landscaping methods that would limit fertilizer, water, and maintenance needs, which would save them money. Engaging youth through school programs, fun community activities, and citizen science would be great to educate the next generation of Tampa Bay stewards. And thanks for tuning in to our presentation.
And then here are the rest of our resources.